Uh, Hello everyone. Um, in this part, we try to have this pseudocode for random search for bin packing problem, and we convert this pseudocode to a Python code. So far, we converted these two lines uh, to a Python code. So which the first one is generating a random permutation, and then we converted the first packing rule to a Python code. And so the combination of these two lines give us a feasible solution. So to do that, we go to Colab. So first of all, before going there, we need to have introduce our problem parameters or the input data. And then we need to define a best solution, which at the beginning is null, the best bins, uh, or the number of the bins, which is at the beginning is huge number. And then we need to do, actually, we also need to have to know the maximum trials. And then we have this outer loop. And then we reach to these two lines. So first of all, we need to uh, define our inputs and the basics that we need for a random search algorithm. So going back to Colab, so first of all we need to import the random library because we want to generate random permutations. So after importing, we need to define the inputs of our problem. Uh, we have 6 items. We don't need to define this list because eventually we need the length of this list, which tells us how many items do we have. So we can just ignore this one. So we have the list weight, which is based on what we had in the lecture. C is equal to 10, and let's say at the beginning we are looking for 1000 trials. And then we need to, if you're going back to this one, we need to define these two variables that eventually are going to store our best solution and its corresponding best value. So the best value, because we have 6 items, in the worst case we are going to have 6 bins, one for each of them. But let's say we have 10 as a worst number to start. So the output shouldn't, definitely the maximum value is 6, but let's say we have 10 here as a bad value for the objective function to begin with. And then we have our outer loop. So going back to the pseudocode, when we have this for loop, then we need to generate a random permutation, and then we need to do the packing based on the rules that we have, which we use the first one. So for this one, for the permutation, I simply go back to the lines of code that we had previously, and I'm just going copy paste this one in our in this file. So what we have here is actually what we tried to do for generating a random permutation. So I just copy paste that line of code. And then what we need to do is to update some of the variables here that we have. So we don't have any a here. So a is actually the list of, and actually we also need the n here. If I go back here, we also need to define n, which is the length of a, which is a is the list of the items. So going back here, so this is the length of list item, or you can simply just have n at the beginning, and let's say n is equal to 6. We have 6 items here, or whatever the number of the items is, and therefore we don't have actually a here, which was in that code was the list of the items. So I'm just going to yeah, actually you need list of items because you need to have the final permutation. Yeah, so let's do this and see what this line does. So because I don't need to do this one, this is let's see what is the output is. Too many sessions. Let me close this one. Okay. Oh, not this. Minus sessions. I don't need 12. I have 16. This one. So here what we have. And see what will be the output. So here is the A. Yeah, of course. Let's see. And here we have control. Let's run it again. Now you can see that these are the permutations that we have. If I choose this one, you know, exactly there's too many. So this is that why we have this 100 or 100 permutations that we generated using the rules, using that the shuffle algorithm. We can also replace this one with the shuffle that we talked about in the first video for the bin packing. So after that, now that we have this list, what we are trying to do is to do the packing and apply the packing rule. So I go back to the previous code that we had, and here is the case that has. So again, we need to just rename some of the variables. I'm then just going to copy paste this block of code, and here we go. After generating a permutation, a random permutation, now what we need to do is to check actually doing the packing, applying the packing rules within this outer for loop. Okay, so we have this one. We can get rid of this print. I'm just going just keep it for now, but eventually we are going to get rid of this one. So we have the bin assignment. So we have b is equal to 1, the remaining capacity, we have the capacity that defines here, it's equal to C, which is 10 in our case. The PI was the item list that we have here right now, so we need to update this variable, rename this variable actually, and also we don't have any W here, which is the list weight in our case. So and here we go. So and everything is fine. So okay, now what we have here is 100 trials. Within each trial we have a random permutation of this list, and then we apply this packing rule, which is which was the first fit, I think. And based on that, yeah, I think it's the first fit. And then based on that, which is the first rule that you had in the lecture, and then we see how many bins we used and what is the bin assignment. So let's run it, and so you can see that for 100 trials, that was too much. Let me make it 10 so it's manageable. And yeah, so we have 10 trials, 10 different permutations. Hopefully we saw previously that they could be the same, but this is the permutation, this is the bin assignment for that permutation, and this is the number of bins that we used. Here we used 4, and this is 4. We used 5, this is 5, and we can see so far that, for example, the minimum number that we see here is number 4, that we used 4 bins. So this is, by end of this line, we are here in our pseudocode. So we generate that numbers, sorry, the permutation, and we apply the packing rule. Now we need to see if this feasible solution is the best that we found so far or not. So going back to the code, what we need to do after this line of code, we said if we need that if statement, if bin used, which is the objective function of which is the objective value of that feasible solution, is less than, we are minimizing, is less than what? The best value is less than best value. What we need to do is to update the best value and best solution. So the best value is going to be equal to the bins used, and the best solution, sorry, best solution is going to be this bin assignment, which is the assignment of that permutation. Okay, so if this is the case, we are going to update them, and we don't need to do anything after that. If this is not the case, we are just going to we don't do anything. And after this outer 4, so let me go back. After that, we need to print our final solution. So print, let's say the best solution is what is the best solution is the best solution, and we print the minimum number of used bins is, this is the best value. Okay, so we have this one. So let's run it again. Again, we have those 10 different permutations, different bin assignment, and the number of bins that is used. And finally, we have, this is the best solution, is 4, 2, 3, 1, 1, 2. And the minimum number of used bins is 4. We used 4 bins, which should be something here in our case. I think, yeah, this is the one. This is the permutation. This is the assignment, and this is the number of bins that we used. Okay, that's yes. This is this. And because we didn't replace with, I think I saw another 4 here. No, all of them are 5. So we didn't have actually any better one. So one thing that we can do is to increase the number of max trial to see if we can get any better solution. first of all, let me deactivate those lines because I don't need to print A all the time, and I also don't need to print them here. So, and if I run it again after 100, this is still the best solution with 4 bins. And finally, let us increase it to 1000, and it's still 4. Let me do one thing. So we have 6 items, so 6 factorial is going to be the maximum number of permutations. And so 6 by 5, so what is 6? I think, I don't know if, no, it's 30, 120, 200, yeah, 100, of course, because there's no guarantee that all of them are going to be different from each other. That makes sense, but I think after 500 trials, there is no need to increase, to have more number of trials to reach a good solution. But here is the case. The 4 is the best solution that we found. Again, there is no guarantee that this is the optimal solution, and this is the best solution using, so for example, the item 1 should be assigned to bin 2, item 2 assigned to bin 4, we assign our third item and the last item to bin 1, and the fourth and the fifth one to bin 3. So here is, yeah, with this I conclude this recording.